Good morning, everyone, and welcome. I'm Dr. S.K. Singh, and I'm delighted to have you here today. Today's presentation is titled Advances in Insert Topic, a fascinating subject that I'm excited to explore with you. Over the next few minutes, we'll cover some key insights, recent developments, and practical implications related to this area. So let's get started and make this session both informative and engaging. Today, I will walk you through the different types of maintenance that are commonly used in various industries. First, we have time-based maintenance, which involves scheduled checks and servicing at regular intervals, regardless of the condition of the equipment. Next is usage-based maintenance, where maintenance activities are triggered after a certain amount of use or operational hours. Then, we have condition-based maintenance, or CBM, which relies on monitoring the actual condition of equipment through sensors and measurements to decide when maintenance is needed. Moving forward, predictive maintenance leverages AI and IoT technologies to analyze data in real time, predicting failures before they happen. This approach helps optimize maintenance schedules and reduce downtime. Meanwhile, preventive maintenance, or PM, is planned maintenance carried out before any failure occurs, aiming to prevent issues proactively. It's especially critical in regulated industries like pharmaceuticals, herbal and Ayurvedic products, and API manufacturing. In these sectors, maintenance isn't just about keeping equipment running. It's about ensuring product quality, maintaining equipment reliability, and staying compliant with stringent regulations. These practices ultimately support the integrity of the products we deliver and the trust of our customers. Let's take a closer look at the equipment lifecycle concept. This model is structured around three main phases: installation, operation, and performance. During installation, we focus on installation qualification, or IQ, to ensure the equipment is set up correctly. Once operational, we move into the operation phase, which involves operational qualification, or OQ, confirming the equipment functions as intended. The final phase is performance, where we perform performance qualification, or PQ, to verify it consistently produces desired results. An important aspect throughout all these phases is preventive maintenance, or PM. Regular PM activities help us keep the equipment in a continuously validated state, minimizing risks and ensuring reliability over time. The scientific basis for this approach is rooted in reliability engineering, failure rate analysis, and comprehensive equipment lifecycle management. These principles help us understand and predict equipment behavior, enabling us to proactively address potential issues. The ultimate goal here is to minimize unexpected failures and reduce contamination risks. By following this structured lifecycle approach, we not only ensure equipment performance, but also safeguard the quality and safety of our processes and products. Let's talk about production equipment maintenance, which is a critical aspect of ensuring quality and safety in our manufacturing processes. For pharma and API production, we use equipment like reactors, granulators, and tablet presses. These tools are essential for producing high-quality medications, but they require regular checks to maintain optimal performance. When inspecting these pieces of equipment, I focus on surface integrity, especially since most of these are made from stainless steel. Like SS316L, keeping the surfaces smooth and intact helps prevent contamination and makes cleaning easier. Seals and gaskets are also vital. They keep the system airtight and prevent leaks, so we always check for any signs of wear or damage. The CIP, or clean in place, and SIP, or steam in place, systems are critical too. They automate cleaning and sterilization, ensuring the equipment stays sterile without extensive disassembly. Regular checks here support consistent product quality and reduce downtime. Now, shifting to herbal production, we have equipment like pulverizers and extractors. These are designed to process plant materials efficiently, but one of our main priorities is preventing cross-contamination. Residues from previous batches can pose risks, so thorough cleaning and maintenance are essential to keep each herbal batch pure and uncontaminated. Overall, whether we're dealing with pharmaceutical or herbal equipment, routine maintenance and diligent checks are key to maintaining product integrity, safety, and compliance across the board. Let's take a closer look at HVAC and cleanroom systems. One of the key components here is ensuring HEPA filter integrity. We do this through DOP or PAO testing, which helps us verify that the filters are performing correctly and preventing any contaminants from passing through. Next, differential pressure control is essential. Maintaining the correct pressure differentials ensures that air flows in the right direction, keeping the clean environment stable and preventing any unwanted particles from entering sensitive areas. Temperature and humidity monitoring are also critical. Precise control of these parameters helps us maintain optimal conditions for product integrity, especially in environments where even minor fluctuations can cause issues. All of these elements, filter integrity, pressure control, and environmental monitoring, are especially vital for sterile pharmaceutical manufacturing and controlled herbal processing. They form the backbone of a reliable cleanroom environment, ensuring safety, quality, and compliance throughout the process. Let's talk about water and utility systems, which are critical for maintaining the quality and safety of our products. When it comes to purified water and WFI systems, we focus on key parameters like conductivity, TOC, and microbial limits. These factors help us ensure that the water used in production is of the highest purity and free from contaminants. Conductivity indicates the level of ions in the water, which reflects its purity. TOC, or total organic carbon, measures organic impurities that could affect product quality. Microbial limits are essential to prevent microbial growth that could compromise safety. On the utility side, we rely on systems like clean steam and compressed air. These utilities must also meet strict quality standards to prevent introducing any contamination. A vital part of this is preventing biofilm formation and contamination in our systems. Biofilms can harbor microbes and are notoriously difficult to eradicate, so implementing proper sterilization and cleaning protocols is essential. Overall, these systems and controls are interconnected and fundamental to ensuring the integrity of our manufacturing environment. They help us maintain compliance and deliver safe, high-quality products to our customers. Today, I want to introduce you to the concept of a mathematical reliability model. This is a crucial tool that helps us understand and predict how reliable a system or component will be over time. Essentially, it provides a structured way to quantify uncertainty and to analyze failure behaviors systematically. By developing these models, we can forecast potential failures, optimize maintenance schedules, and improve overall system dependability. Throughout this presentation, you'll see how these models connect to our broader goal of enhancing reliability and ensuring safety. They form the backbone of data-driven decision-making in reliability engineering, enabling us to make smarter, more informed choices. So, understanding this model is key to mastering how we assess and improve system performance over its life cycle. Now, let's turn our attention to laboratory equipment maintenance. This is a critical aspect of ensuring our instruments perform accurately and reliably. In our lab, we primarily use instruments like HPLC, GC, and UV spectrophotometers. Each of these tools plays a vital role in our analytical processes. Regular maintenance activities include calibration, which ensures the instrument's measurements are accurate and consistent over time. System suitability testing is also essential. It helps us verify that our instruments are functioning properly before starting analyses. Another important aspect is software compliance, particularly related to data integrity. Ensuring our software systems are compliant helps us maintain the authenticity and reliability of the data generated. All these activities tie back to our overall goal, maintaining high standards of quality and accuracy in our work. Proper equipment maintenance isn't just about keeping machines running. It's about safeguarding the integrity of our results and, ultimately, our confidence in the data we produce. Let's talk about some of the specific challenges faced by the herbal industry. One major issue is variability in raw materials. Since herbs can vary based on growing conditions, harvest times, and processing methods, maintaining consistency can be quite tricky. This variability can impact the quality and efficacy of the final product. Another challenge is residue buildup in equipment. Over time, residues from herbs or cleaning processes can accumulate, which not only affects product purity, but also poses contamination risks. Moisture and microbial contamination are also significant concerns. Herbs are organic and susceptible to mold or bacteria if not properly handled and stored, which can compromise safety and quality. That's where preventive maintenance, or PM, becomes essential. Proper PM helps ensure effective cleaning validation, meaning we verify that our cleaning processes are actually removing residues and contaminants. It also helps us maintain consistent extract quality, which is crucial for customer trust and regulatory compliance. Overall, addressing these challenges with diligent PM practices is key to producing safe, high-quality herbal products. Let's take a look at the advantages and limitations of this approach. First, on the advantages side, one key benefit is that it helps ensure GMP compliance. This is crucial because it guarantees that our processes meet the necessary quality standards and regulations. Another important advantage is that it can significantly reduce downtime. When processes are streamlined and well documented, we spend less time troubleshooting and more time producing quality products. Additionally, it often leads to an improvement in product quality, since consistent procedures and better control translate into better outcomes for our end products. Now, turning to the limitations, one of the main challenges is the high documentation effort involved. Keeping everything properly recorded can be quite labor-intensive and requires meticulous attention to detail. It also requires skilled personnel who are trained to handle these processes accurately. Without the right expertise, maintaining compliance and quality can become difficult. Lastly, implementing these methods often involves an initial cost investment, which can be a hurdle for some organizations. But as we've discussed throughout this presentation, weighing these limitations against the benefits is essential for making informed decisions about quality management. Let's take a closer look at this checklist example. First, it's important to thoroughly explain each key point, but do so in a conversational way that keeps the audience engaged. As we go through, we want to highlight the most important concepts so they stand out. Remember, these points are connected to our overall presentation theme, so make sure to tie them back to the bigger picture. This helps reinforce how each step or item fits into the broader context of what we're discussing. By approaching it this way, we can make the information clear, memorable, and relevant to our audience. So, to wrap up, let's emphasize that preventive maintenance is absolutely critical when it comes to regulated manufacturing environments. It's not just about keeping machines running, it's about ensuring compliance, quality, and safety. As you can see, it integrates several key aspects: engineering, which involves the technical upkeep; quality assurance, making sure products meet standards; and regulatory compliance so we stay within legal and safety frameworks. Looking ahead, the future of maintenance is moving towards smart solutions. Think AI and IoT. These technologies will enable us to predict issues before they happen, making maintenance more proactive and efficient. And the most important takeaway here is that maintenance isn't just a technical task. It's directly linked to product quality and, ultimately, patient safety. If we maintain our equipment well, we protect the end user and uphold the integrity of our manufacturing process. So, remember, effective maintenance is a cornerstone of delivering safe, high-quality products in regulated industries. For further support, please don't hesitate to contact us. We're here to help you with any questions or additional information you might need. Remember, our goal is to ensure you feel confident and well-informed moving forward. Thank you so much for your time and attention today. We truly appreciate your engagement and look forward to supporting you in any way we can.